Dragan Veselinovic from Green Imaging Technologies. Today I'm going to talk about the operations and setup of the NMR overburden cell that was designed by Oxford Instruments and Green Imaging Technologies. So this is the 1-inch overburden probe. First I'm going to identify all the different pieces of the probe when it's disassembled. This is how it's usually shipped. So this is the main part of the probe, body. This is the bottom cap of the cell, top cap. These are floating plugs that are attached to the stems that will hold the sample and go inside the probe. These are the HIP fittings that are attached to the stems once the sample is inserted. These are used to connect high pressure lines to the probe. And finally, this is a set screw that's used to hold the bottom cap in place when it's inserted in the bottom of the probe. First thing I'm going to do is I'm going to insert this bottom cap and put the set screw in place. So the way to do that is we'll just insert the bottom cap at the bottom. Needs a little bit of force to push it in, and then we will twist it so that it sets into place. Once it's set into place, we identify a hole on one of the sides of the probe in which we insert the set screw. So to insert the set screw, we will use a hex key, a long one, like this. And then we will just rotate it until it's threaded all the way in. Once the set screw is in, you shouldn't be able to rotate the bottom cap. Once the bottom cap is inserted, the cell is ready to go into its holder. So now the cell is ready to go into its holder. This holder is designed to hold the cell while its operation outside of the magnet, so all pressurization and flow should be done in this holder. Once the main part of the probe is in the holder, we're ready to prepare a sample and put it into the cell. And then after that, we'll pressurize the cell and show how we can do some flow studies using the cell. To prepare a 1-inch sample for insertion into the overburden probe, we will need a heat shrink, a heat gun, a knife, and the 2 stems and floating plugs that are part of the probe. So the way we insert the sample is, first we will insert one of the floating plugs and stems into one end. Then we will insert the sample to the other end. And then we insert the second stem and floating plug to the other end to sandwich the sample between the 2 floating plugs. This is just to give it an approximate length of the heat shrink that we will require. So once this is done, we can cut off part of the heat shrink at the desired location. Okay, so that one's good. And now we can use the heat gun to heat shrink these three pieces together. Okay, so this looks good. Once this is done, we will cut off the excess part of the heat shrink. Otherwise, this will not fit into the probe. Okay, so now the sample is ready to go into the probe. So to insert the sample into the overburden probe, first we will push the long stem through the top cap of the probe. Usually it's a good idea to lubricate the stem a little bit using vacuum grease, just to make it go smoother. Let's go a little bit here on the threads. Doesn't require very much. And now we just push the long stem through the top cap. Okay. And now the sample is ready to be inserted into the probe. Push it in. Once it sits in place, we twist it. And the sample is in. That's all there is to it. And now we're ready to attach the probe to the pump. But before we do that, we need to make sure that these HIP fittings are connected to the probe properly. So the way to do that, we'll do the bottom one first. First I'll just show what they consist of. Once we unscrew the part of the fitting, there's a ring inside the fitting that will screw onto the bottom stem. So the way to do this is we'll put the top part of the fitting first, and then we will screw the ring onto the stem. And these rings are actually threaded in the opposite way from normal bolts. So to thread this on, we thread it counterclockwise, as opposed to most regular threads. And once that's attached, it only needs to be finger tight. Once that's attached, we can put the rest of the HIP fitting in. So this part threads normally like any other thread. And this part will need to be tightened a little more. So we'll use a 5/8 wrench to hold the bottom part, and 1/2 inch wrench to screw in the top part. So it only needs to be tightened to about 1/4 turn, so not too tight, otherwise it can damage something. Okay, that's good. The next thing to do is do the same thing for the top part. So we will open up this, make sure that the ring is here, which it is. So I'll put this first, then we thread the ring. Counterclockwise again. Then we reattach the fitting and tighten it using the same wrenches. About a quarter turn. So now the probe is ready to be attached to a pump. At this point we can attach the pump either from top or from the bottom of the probe to flow the fluid in either direction. We can also attach it to the confining ports to increase the confining pressure. Now we're ready to connect the probe to the pump and increase the confining pressure, or I guess introduce confining fluid around the sample. To do this, we will use the confining ports that are on the top cap. First, we have to make sure that the ports are open, and to do that, we'll just use a little wrench. This is number 8 metric to open these ports. So we'll just unscrew the copper screws here. We will open them both initially. Once they're open, we can connect the pump to the port. In this case, this is just a standard swage lock fitting that's connected to a high pressure line, and that line is connected to the pump. So we'll just get this fitting connected here. So in this case, the fitting requires a 7/16 wrench to be tightened. Once again, be careful not to over tighten this. It only requires about a quarter turn beyond finger tight. Okay, and now we're ready to start flowing the confining fluid into the probe. Usually, if we want to do NMR studies with the probe in the instrument, we will want to use confining fluid that doesn't have any NMR signal. Usually that will be fluorinated oil. In this case, we're just demonstrating operation on the bench, so we'll just use regular water. So now we're ready to start the pumping process. Okay, now we will turn the pump on. To make sure the confining department is filled with fluid, we left both of these ports open, so the confining fluid is coming in through here. It fills the confining compartment, and once it's full, it will start coming out of the other port. When this happens, we will close this port and let the pump do its job in pressurizing the overburden probe. Depending on the flow rate, this process can take a few minutes. So we see the fluid coming through here. This means that the compartment has been filled. Now we can shut off this port. We just use the same wrench to tighten the copper lead screw. And we do have a bit of a leak here, so we just clean it up. If we're using chemicals other than water, we should be wearing gloves and other safety gear. So now we will start the pump again and get the probe pressurized. As you notice, there's a little pressure gauge on the top cap of the probe, and we will monitor this to make sure we don't go over the specifications for this cell. And yeah, we're good to go now, so if you can start the pump, please. So the gauge is slowly creeping up to about 1000 psi, at which point we will stop the pump and we will close off the other port. So this is about 1000 psi. We'll close this port. So at this point we have 1000 psi of confining pressure, and now we're ready to flow fluid through the sample. This means that the sample has to be permeable enough to be able to allow fluid at less than 1000 psi of pressure when it's applied from the bottom. So as a rule of thumb, we want this pressure to be about 200-300 psi less than the confining pressure. So when we're flowing the fluid, we will not go over 700 psi. Once we have the desired confining pressure in the probe, we can, and once the ports are closed, we can now disconnect this line that goes to the pump, just like that. And the probe is actually safe to carry while under pressure, so if we wanted to carry it to another location, we could just pull it and carry it. We're going to do flow from bottom of the probe and the sample upwards. So we will connect the pump outlet line to the bottom of the probe. There's a 1/2-inch wrench once again. And a 5/8 if it's thinner. Not too tight. So our confining pressure is still holding, so we can now start the pump to get the flow going through the sample. So we will do that. So the pump is started, and the fluid should be reaching the sample and going through slowly. and we expect to see fluid come up here on top in a couple of minutes. In this case, we're just flowing water, regular water. But any fluid can be used, and if flowing 2 fluids at a time is desired, a T connection can be used on the bottom where we feed. For example, if you want to flow oil and water, we can flow oil through one side of the T and oil through the other side, and when they mix, they'll go through the third port and enter the probe on the bottom. Okay, so we have breakthrough. So the water is coming through the sample and exiting through the top stem. So this basically demonstrates how one can use this overburden probe to flow fluids at high pressure through the sample.